So if I'm talking angle of elevation, what I'm talking about is if we're looking from horizontal and I elevate, that means I'm going to look up, and my angle of elevation is that theta angle right there. If I'm talking angle of depression, let's see if the yellow works. Here's my horizontal. Depression means I'm going to push down. You depress something, it goes down. So here is from horizontal down, and then my theta angle would be this angle as you're looking down. So angle of elevation, you go up, you elevate. Angle of depression, you go down, you depress. So then they're going to give you a story problem. So here we go. We have an example. I made this one up. I'm kind of proud of myself. We have Jonathan. He's outside looking at the birds because he's out of school. And he noticed this bird just skims right across the top of this big old tree on this yard. So he wants to know, if I tie a string to an arrow and I shoot it to the top of that tree, how much string do I need to make sure I have on the coil? And to figure that out, I'm probably going to want to know my angle of elevation. So let's go, and like always, we want to go into the story problem and find the important numbers. So I've got a 27 foot tall. I'm going to find the string, and I know it's 63 feet from where we're going to shoot this arrow up to the base of the tree. So let's draw ourselves a picture. The key to all of these, folks, is to draw yourself a picture. So here is where pencil. Here is where I'm standing. Here is my tree. This is the only kind of tree I can draw, so this is what you're getting. I'm going to measure the distance to the base of the tree, which we said was, the distance is 63 feet. So I'm going to put my numbers right on my diagram, including my units. The height of the tree from up here down to the ground is 27 feet. 27 feet. And the question asked is, what is the angle of elevation? Well, the angle of elevation is going to be the angle that if this is your head and you look up to the top of the tree, then we can say, okay, the angle of elevation is going to be this theta right here. So maybe I should have said Jonathan's laying on the ground. I don't know. We're going to measure from the ground level, from his eye. Assume his eye is at ground level. So if I want theta, then I got to ask myself, what parts of the triangle do I know? Because I have to pick a formula. I have sine, I have cosine, and I have tangent. So I got to pick a formula that's going to be useful. You know from algebra that if you have an equation and you want to get a number out of it, you can only have one unknown in your equation, which means since all of these formulas have places to put three numbers, we have to pick a formula that will use the two numbers we know, and we'll be able to solve for the one that we don't. Well, we're going to be solving for theta from our angle theta. I'm going to color code just because I can. From our angle theta across here, this is our opposite side, so I'm going to label it right on my diagram with that OPP because it makes it a whole lot easier when you start plugging your numbers in. And right next to that angle theta is my adjacent side. So the formula that has opposite and adjacent in it, opposite and adjacent both, is right here. I got my tangent formula. So I'm going to start by writing my formula. Tangent theta, notice I didn't say tan, I said tangent, is opposite over adjacent. So your first step is write your formula. Second step, plug your numbers in. Tangent is an operation on the angle. I don't know the angle, so I'm going to leave the theta there. Opposite side, I can now look and see my pretty green OPP, and now I just grab the number 27. Over my adjacent side is 63. Then if I want to get to the theta, I'm going to need to undo this tangent, so the inverse operation of tangent is tangent inverse. Whatever I do to one side of the equation, I do the same thing to both sides, so we're going to kind of squeeze it in there. And that's going to leave me with theta all by itself, which is what I want. On the right side, I see what I need to do is a tangent inverse of a 27/63. Now this is a degree measure, so we're going to open up. I think you'll be able to do this with Desmos, so I'm going to see if I can do this too. I'm going to open up Desmos, and in Desmos, come on little Desmos. In Desmos, the first thing we're going to want to do, since our angles are in degree, is we're going to go to this little wrench at the top of the screen, and we're going to change from radian mode to degree mode. Then I'm ready to just type in what I need. I have it written on my paper, so I'm just going to go down to my functions. Now, my screen has the functions already on it. You might have to push your keyboard over in the bottom left side. So I'm going to go to my functions. I'm going to find my trig function, so it's my first tab. I'm going to find tangent inverse. Now it pops up over here on the left side. I want tangent inverse of, was it 27 divided by 63? And notice your angle pops up in your, ouch, oh, it was 21, wasn't it? That's why it looked funny. Let's make that 27 at 21. Was it 27 or 21? I don't remember what I said. Let's go back. Come on. Maybe I'll just make it 17. Let's go back. Oh, I know what I'm doing. Let's go back. Let's try 27. So now we've got, there it is, sorry about that. Now I've got my 23.19 degrees just popping right up on the screen in that box where I type stuff. Notice no graph shows up. We're just going to use it as a calculator. So I can go back to my paper, maybe. Here it is. And I can write theta equals, what did we say, 27.19 degrees. Did I remember that right? I'll go back and check real quick. That was silly. 23.19. 20. Backing up. It's weird. I'll go back to my pencil. 198 degrees. And that's how you do it. Remember, you can stop, pause, rewind, go back, redo things. You can skip over my mistakes. Have fun with this, guys. Miss ya. Bye.